Hey everybody, it's Ms. Casbaro. This is Measures of Central Tendency. It's 14.2, the second one that we've got. And this was to find the mean, median, and mode, and put the data in a stem and leaf plot. Alright, these are numbers of new Broadway shows that opened, and when we get to the end of this, we'll find the average number for these seasons. Alright, so it opens up with general term of finding the mean. This is the symbol for the mean. It's X with a line over it, and when you find the mean of values, that's how it's going to appear on your calculator. Okay? I am missing my calculator up here, but that's alright. The X with the bar over it will be the number that you're looking for. Okay, so when we're finding the mean, you are going to add up every single item that you've got and then divide it by the number of items that you have. So when you add them all up, you get 161 divided by 7, which is 23. So the mean is 23. Now, for some notation, this is a sigma in Greek. It's a capital sigma. It stands for summation, which means that we are adding together the values we generate from the operator. The start point is usually listed at the bottom down here. The stop point is listed at the top. The notation, I'm going to clear it up for you, hopefully, when we come through. Right here, so K equals 1. Starts at 1 and it stops at 4. This is what you actually do to solve this problem because the answer is a single number. So you're going to have 2 times 1 plus 1. That's your first item. Then you do it for 2. 2 times 2 plus 1. Then you do it for 3. 2 times 3 plus 1. And then you do it for 4. And that's your stop point. 2 times 4 plus 1. So, right here you get 2 plus 1. Then 4 plus 1. Then 6 plus 1. And then 8 plus 1. So we end up with 3 plus 5 plus 7 plus 9, which is 8, 15, 24. So the answer, if you just had this on a problem on your paper, it would actually be that this right here equals 24. Okay. Now, sometimes it's listed like this. That means the first term plus the second term, whatever that is, plus the third term plus the fourth term. And that comes from this right here, this type of notation where you've got x sub 1, x sub 2, x sub 3, and x sub 4. It just means there are 4 particular numbers that must be added. So if you had this kind of notation, it would just mean whatever that term is, it's the first one. We're adding the first through the fourth term. Okay. Here are some other examples of your sigma notation. So right here it starts at 2. You'd have 2, 3, 4, 5, 6, and 7. So I'd have 2 squared minus 2 squared plus 3 squared minus 2 cubed plus 4 squared minus 2 to the 4th plus 5 squared minus 2 to the 5th plus 6 squared minus 2 to the 6th plus 7 squared minus 2 to the 7th. You see how wherever I have an n, That's where my 2, 3, 4, 5, 6, and 7 goes. 2 squared, 3, and then 2 cubed, 4, 2 to the 4th. Everywhere you have an n is where your number goes in that you're substituting in. 2 squared minus 2 squared, well, that's just 0. This is 9 minus 8. 4 squared is 16 minus 2 to the 4th is 16. 5 squared is 25, and 2 to the 5th is 32. 6 squared is 36, and 2 to the 6th is 64. 7 squared is 49, and 2 to the 7th is 128. So we're going to have 0 plus 1 plus 0. 25 minus 32 is a negative 7. 36 minus 64 is a negative 28. And then 49 minus 128 is a negative 11 minus 4, 79. Double check that, yes. Alright, so add all these up and you get 35. And that will be 114. 1 minus 114 is a negative 113. So that's your answer for this. Okay. So one more. Everywhere I have a K, I'm going to put this in. 2 times 4 plus 3. Then I'm going to go to 5. 2 times 5 plus 3. Then to 6. 2 times 6 plus 3. And then to 7. 2 times 7 plus 3. And then to 8. 2 times 8 plus 3. So you have 8 plus 3 is 11. Okay. 10 plus 3 is 13. 12 plus 3 is 15. 14 plus 3 is 17. And then 16 plus 3 is 19. So we have 24 plus 32 plus 19 is 56 plus 19, or 75. And that's your total for the summation notation. And that's where I'm going to stop this particular video so we can make sure everybody's got everything that they need to understand here before we go on any further. Okay. Hi, there's one final note here. If you see a summation that looks like this, and it goes to infinity, obviously you're not going to be able to add all the numbers to infinity. But that's where this formula comes in. You'll see it on your formula sheet that I gave you out earlier. It just means A, the first term right here, which is going to apply to this, over 1 minus the ratio, which is going to apply to this, is going to give you the sum. So when you see something that looks like this, you would say that the sum is going to equal 5 over 1 minus that ratio, 5 over 1 minus 3/4 is 1/4. 5 divided by 1/4 is going to equal 5 times 4, which is 20. And that will give you the sum of an infinite summation there.